When a major cloud provider sneezes, the internet catches a cold. Mike Chapple, professor of cybersecurity, University of Notre Dame, said in a CNBC interview, a global AWS disruption highlights how deeply drone operations rely on cloud infrastructure and why resilience matters. Amazon Web Services experienced a widespread outage this week that interrupted access to millions of websites and applications around the world. Reports showed the heaviest impact in the United States and Europe, where users could not log into online services or access stored data. For most people, the incident meant frustration when streaming or shopping online. For the drone industry, it raised an important question. How would drone operations respond if a similar outage affected the systems that support flight management, mapping, and data delivery? How drones depend on the cloud. Modern drone operations are built around cloud workflows. The cloud stores flight logs, imagery, telemetry, and maintenance records. It hosts the dashboards used by pilots, managers, and clients. It also powers the artificial intelligence that turns images into maps and 3D models. Many drone software providers use cloud services such as AWS, Google Cloud, or Microsoft Azure to run their infrastructure. During a large-scale cloud incident, authentication errors or data routing failures could make it harder for pilots to log in or for teams to upload imagery for processing. In this week's case, impacts varied. Some cloud-connected services reported short-term errors or slow response times. Others reported no effect at all. The incident serves less as evidence of failure and more as a reminder that drone ecosystems are closely linked to global internet stability. Potential disruptions across the sector. Cloud interruptions do not always ground drones, but they can limit connected functions. Public safety teams that use drones as first responders rely on live video and dispatch systems hosted online. A temporary break in service could delay streaming or restrict remote access to mission data. In industries such as construction and energy, upload delays could slow data processing and project timelines. For regulated sectors like utilities or defense, any pause in telemetry synchronization might affect record keeping. Most aircraft can continue to fly and record locally when cloud systems fail. The features most affected are live dashboards, AI analytics, and queued processing that depend on constant connectivity. The real issue: single points of failure. The AWS incident shows how modern technology, including drone software, is concentrated within a few large providers. Many systems rely on shared DNS or authentication services that can affect multiple regions at once. This is not a problem unique to drones. Banks, hospitals, and logistics companies face similar concentration risks. Yet in aviation, where safety and reliability are essential, dependence on a single cloud region or identity provider becomes a critical concern. The key takeaway is not which platform was affected, but how the sector as a whole plans for continuity when connectivity is interrupted. Building a more resilient cloud strategy. Drone technology providers are taking steps to increase resilience. Multi-region replication allows data and services to shift automatically between locations when one becomes unstable. Some companies are exploring multi-cloud architectures that combine different providers to avoid a single point of failure. Edge computing and offline modes also play an important role. When drones can continue to capture and store data locally, operators can maintain mission progress even if network connections are lost. Once restored, the data syncs automatically to the cloud. Enterprise and public agencies are also adopting private network links and local DNS configurations to keep essential services running during large internet events. Clear communication through public status pages and service-level agreements builds transparency and trust. A lesson for connected aviation. The recent AWS outage is a reminder that the world of connected flight is only as strong as its supporting infrastructure. While this particular event did not cause broad operational disruptions in the drone industry, it underscored the importance of designing for resilience. As drones become a routine part of emergency response, mapping, and logistics, their dependence on the cloud becomes a matter of operational safety as well as convenience. The next time a major provider experiences problems, the systems that have built redundancy and local control will continue to operate. Those that have not may find their workflows paused until the network recovers. In connected aviation, resilience is not optional. It is as vital to safety as the airframes and batteries that keep drones in flight.